Hi students, coming to the next topic in the subject compiler designs was operator precedence parsing. So in the previous video I explained about the shift reduce parsing. Now let's see the next concept, that is the operator precedence parsing. Any grammar G is called an operator precedence grammar if it meets the following two conditions. So when we can say that the grammar, whatever the grammar we are taken, that is an operator precedence grammar, whenever it follows these two conditions. So what are these two conditions that the grammar has to follow? The first condition was there exists no production rule which contains epsilon on the right hand side. The first thing is there should not be epsilon on the right hand side. Whatever the production that we are taken for the grammar, that production which does not contains epsilon on right hand side. Okay, and there exists no production rule which contains two non-terminals adjacent to each other on its right hand side. So whatever the elements that are present on the right hand side of a grammar, okay, so no two non-terminals. Non-terminals means it's alphabets, the letters we are using. Okay, so those non-terminals should not be side by side. So if that grammar follows these two conditions, then we can say whatever the grammar that we are taken is an operator precedence grammar. Okay, don't be confused. Any grammar, whatever the grammar you are taken, the grammar is just represented like suppose E tends to E plus E and E tends to E star E. Okay, like that. So this is an example of the grammar. So here there exists no production rule which contains epsilon on right hand side. So right hand side there should not be right hand side, this is okay. No epsilon on right hand side. And there exists no production rule which contains two non-terminals adjacent to each other. So these two non-terminals should not be adjacent to each other. Then we can say the grammar is operator precedence grammar. Okay, don't be confused. If you see the example, then you'll get a clear idea about operator precedence parsing. So the thing is, you have to remember these 2 points. Whenever the grammar is following these two conditions, then we can say that grammar is in the form of operator precedence grammar. A parser that reads and understands an operator precedence grammar is called operator precedence parser. So whatever the parser that reads and understands the grammar, you call it as an operator precedence parser. So let's see which grammar you call an operator precedence and which is not operator precedence. So that by seeing this example, you get a clear idea what are those two conditions that we are discussing about. A grammar which is not an operator precedence. Let's see not an operator precedence grammar. If the grammar is like this, we can say it is not an operator precedence. Why this grammar is not an operator precedence? Because the terminals are adjacent to each other. These are the non-terminals. These non-terminals are side by side. E is a non-terminal, A is non-terminal, E is non-terminal. So here all the terminals are together, adjacent to each other. So that's why this is not an operator precedence grammar according to our condition. Okay, so how you can make this not an operator precedent grammar to a precedent grammar? See here. So this grammar is converting by substituting the non-terminals. Okay, by substituting the terminals, then you'll get an operator precedence grammar. See here. So this is not an operator precedence, and here this is an operator precedence grammar. So E tends to, in place of in the place of A you can write plus, minus, into, divide, and. Okay, so E plus E, E minus E, E into E means in the place of A you are just substituted these terminals. So E minus E ID. So we are converted this not an operator precedent grammar to precedent grammar, operator precedent grammar. So if there exists no production rule which contains epsilon right hand side, that condition 1 has to be followed, and there exists no production rule which contains two non-terminals adjacent to each other. So no two non-terminals are adjacent to each other. So here these are the non-terminals. These non-terminals are not adjacent to each other because in between that there is a terminal is there. The plus, minus, into, these are all the terminals. And the non-terminals are the letters E, A, E. These are all the non-terminals. So operator precedence can only establish between the terminals of the grammar. So the thing you have to remember that operator precedence can only establish between the terminals of a grammar. So this is between the terminals of a grammar. It ignores the non-terminals. So it just ignores the non-terminals. Okay. So let's see an example. So before discussing the example, you have to know some rules about parsing actions. So what are the parsing actions that we have to be take care while we are constructing an operator precedent parser tree? Okay. So parsing action. Both end of the given input string add with dollar symbol. The first condition is both the end of the given input string, whatever the input string we are taken, so that input string will be add with a dollar symbol on both sides. Second, now scan the input string from left to right until greater is encountered. Scan towards left over all the equal precedents until the first less is encountered. Everything between leftmost is less than and rightmost is greater than is handled. Everything between leftmost is less than and rightmost is greater than is handled. Dollar and dollar means parsing is successful. So these are the rules that you have to be remember while you are parsing the tree. Okay, parsing the table. So here there are, I said the greater, less and equal, what are those, all those things. Let's see here. There are three operator precedence relations or you have to be followed. The three operator precedence relations. A greater than B means the terminal A has higher precedent than B. Terminal A has lower precedence than B. Terminal A and B have same precedence. Okay. So this is the condition. Let's see how to construct a precedence table. So whenever you are discussing about the operator precedent parser, the first thing is you have to check whatever the operator precedent grammar that we are taken, that grammar is in operator precedence grammar or not. And the second is you have to see the precedence relation table. So how the precedence relation table has to be constructed. Let's take some of the terminals, the plus, into, okay. So these are all the, let's see what are the rules that you have to follow while you are constructing the precedence table. Always think the ID A, B, C. Okay, these terminals should be high precedence. They are having the high precedence. Whereas the dollar, okay, that is the acceptance string, the dollar is low precedence. So plus, if both are the plus, the left hand side should be greater than. Plus is greater than plus. And star is greater than star, and ID is not equal to ID. So whenever the both IDs are encountered, those are not equal to. So you have to place blank there. And if suppose $2 are encountered, then your string is accepted. A, accepted. So plus is greater. So here this plus terminal A has higher precedence than this plus terminal. Plus star, so when compared to plus and star, the star into is having the higher precedence. So that's why here less symbol. Plus is less than star, and less than, greater than, ID less than and greater than, like that. So you have to construct the precedent table by following these rules. Okay. So we had seen some operator precedence relation rules, and based on the rules we have constructed the precedence table, and we learn what are the actions that you are to be understand while you are constructing the parsing. Okay. Now let's see a simple example. By seeing this example, you will get a clear idea what is operator precedent parser. So consider the following grammar and construct the operator precedent parser. So by considering this grammar, we have to construct the operator precedent parser. Then parse the following string. After finding out the operator precedence parser, you have to parse this string. The string is given and the grammar is given. Now we need to construct the operator precedent parser. Okay. So while you're starting, what are the steps you have to be followed while if you want to construct the operator precedent parser? The first step contains, step 1 is you have to check operator precedent grammar or not. So whether the grammar, whatever the grammar that is given, that is in operator precedent grammar or not. This is operator precedence grammar or not, we have to be check. Okay. And the step 2. The step 2 is we have to construct the operator precedent relation table. Construct the relation table. First, convert the grammar into operator precedence grammar. Next, you have to construct the relation table. And step 3. In the step 3, you need to parse the given string. Whatever the string they are given, you have to parse the string. So, step 4. And finally, you need to generate a parse tree. Generate parse tree. So, these are the steps you need to follow. The first thing is check whether the grammar is operator precedence grammar or not. And step 2 is next you have to conduct the find out the relational table. After, by seeing the relational table, you need to parse the string. So with the help of the parse string, you are going to generate the parse tree. Okay. Now let's see the first step. Convert the given grammar to operator precedent grammar. So here whatever the grammar that they are given, that is not an operator precedent grammar. Why it is not operator precedent grammar? Because here the non-terminals are side by side. Okay. So to replace this, we have to substitute in place of a the plus and into we have to substitute. So just substitute the values and make the grammar as an operator precedence grammar. So E tends to E plus E, E into E and ID. Okay. And coming to the step 2. Okay, now the step 1 I converted the grammar into operator precedent grammar. Next I need to construct the operator precedence table. Second step is operator precedence table. So here what are the terminals? And the non-terminals are EA or the non-terminals, and the terminals are ID plus into as well as the dollar. So these are the terminal symbols. Okay. So now construct the only for the terminal symbols we are going to construct the table. We are not focusing on the non-terminals. The operator precedent grammar, operator precedent will just remove the non-terminals, only takes the terminals. So ID plus into dollar. Okay. According to our rules, ID is having the highest priority. Okay. ID is having the highest priority and dollar is lowest priority. So whenever the plus and plus are there, plus is greater than plus. Okay. Into is greater than into. Okay. So ID is not acceptable, not equal. ID is greater than plus, ID is greater than into, ID is greater than dollar, because ID is having the highest priority. And coming to the plus, plus is less than ID because ID is highest priority. Plus is greater than plus. Okay, whenever the left hand, this side is greater and here it is lesser. Plus is always less than into and it's greater than dollar because dollar is having the low priority. Into is less than ID, multiplication is greater than addition, multiplication is greater than multiplication, and it is greater than dollar. And coming to the dollar, dollar is having the lowest priority, so all are less. And whenever the dollar and dollar is encountered, the string is accepted. Okay, so I constructed the operator precedent table. Now step 3. The step 3 is we have to parse the given string based on the table. So how I am going to parse the tree? So let's take the string as an input string, and this is the grammar. Okay, now the stack contains, the stack first contains the dollar and the input string ID plus ID star ID dollar. Okay, so the first is I have to shift the ID onto the stack. So I shifted ID to the stack. So after shifting the ID, here I need to check the relation dollar and ID. So dollar ID, dollar is less than ID. So place less than symbol. Okay, so I shifted id. Now here plus id star id. So from this id and plus, what is the relation between id and plus? Id and plus, the greater relation. So id plus greater. So after that I have to shift, reduce the id. So id, what is id? id is replaced with the non-terminal e. Okay, so reduce e tends to e produces id. So replace id with e. So e less than plus id star id and dollar. So here why I taken less? Because you have to check the relation table only with non-terminals, not the only with the terminals, not non-terminals. So just compare dollar and plus. So dollar and plus, what is the relation? Dollar is less than plus. So that's why here less than symbol. So now shift plus. Okay. After shifting plus, id star id dollar. Now check the plus and id. So plus and id, what is the relation? Plus id less than symbol. So just place less than symbol. Now shift id. Now star. Okay. So id here will be id and star. id is greater than the star. id is always having the highest priority according to our table construction. So greater than relation. Now I have to reduce the stack here. I want to replace with the non-terminal. So reduce id with e. Means in place of id just place non-terminal e. This is the equation. Now shift star. When compared to star and id, star is having the less priority when compared to id. So less than symbol. Now shift id. Okay. So in place of id and dollar, id is having the highest priority. So greater than symbol. Now reduce e produce id. So in place of id, just replace with e. Dollar. Okay. So here input string is empty, but I need to reduce the stack also. Now e into e. So according to our grammar, e into e is nothing but e. So replace e into e as e. So again e plus e is tends to e. So replace e plus e as e. Okay. So here I check the relation between star and dollar. The star is greater than the dollar. So greater than symbol. And here this you are not checking with the non-terminals, only with the terminals. So plus is plus and dollar. The plus is having the highest priority when compared to the dollar. So greater than symbol. Okay. So now e. So we have to check between the dollar and dollar, not with the e. Okay. Dollar and dollar means accept the string. Dollar and dollar accept the string a. Finally you get the accept string. Okay, that's third step is over. And the final step for the operator precedent parser is you need to generate a parse tree based on the stack. By seeing the stack table, you have to follow the bottom-up approach. To construct the parse tree. Okay. So just take first e. So e is replaced with e plus e. So e is, again I am writing, replaced with e plus e. Okay. In the second step, this e is replaced with e star e. Okay. So now this e is replaced with e star e. E star e. And here this e is replaced with id, and finally this e is replaced with id. So just replaced with id. And finally this e is replaced with id. So constructing the parse tree is very easy by seeing the relational that is parsing the string table. Okay, just follow the stack and follow the bottom up approach by using the stack table and construct the parse tree. So this is about the operator precedence grammar. Thank you.